Hello class 7. Welcome to the second half of the chapter Element, Compounds and Mixtures. Today we'll deal with different types of mixtures and the separation of different ways in which we can separate the mixtures. It's a very simple chapter. So last class we talked about the properties of compounds and mixtures. Today we will talk about we'll start with the types of mixtures. So, what is a mixture? A mixture is an impure substance in which the components are mixed together in any proportion. Okay. So that is a mixture. So types of mixture, there are two types of mixtures. One is a homogeneous mixture and the other is heterogeneous mixture. A mixture is said to be homogeneous if its constituents are uniformly mixed together. Okay. And heterogeneous mixture is a mixture in which the constituents are not uniformly mixed together. So that is the homogeneous mixture and the heterogeneous mixture. So homogeneous mixture, let me give you an example. Brass. You have seen? You have heard about brass, you have heard about bronze, we have heard about stainless steel, we have heard about sugar solution, we have heard about salt solution and so on. These are homogeneous mixture, a mixture in which the constituents are uniformly mixed together. For example, bronze, as I already told you, it's an alloy. It is a mixture of two metals, copper and zinc. Brass is a mixture of copper and zinc. Bronze is a mixture of copper, zinc and tin. Whereas stainless steel, you must have heard, it is a mixture, homogeneous mixture of iron, nickel, chromium and carbon. So let me talk about the homogeneous mixture that we have, we can have it at home. You take a glass of water and you put one spoon of salt or sugar, one spoon of salt or sugar, and then you stir it. You put it in the water and you have a salt solution now. We have a salt solution. Okay. And divide the salt solution into three halves. The first half, third, second and the third. Now you taste all the parts of the solution. Ultimately you will find that they will taste the same. Why? Because it is a homogeneous mixture. Okay. A homogeneous mixture is a mixture in which the components are uniformly mixed together. Heterogeneous mixture is a mixture in which the constituents of the mixture are not uniformly mixed. For example, mortar. Mortar is a mixture of sand, lime, cement and water, isn't it? Sand, lime, cement and water. You mix it in any proportion. So mortar is a very good example of heterogeneous mixture. Like for example medicines, isn't it? Now medicines, especially the tonics or the syrups, we shake it well before use. Why? To make it a homogeneous mixture. Why? Otherwise the constituents of that particular syrup are not uniformly mixed together before having it. So after shaking it, we mix it properly, make it almost a homogeneous mixture, then we consume it. So states of constituents of mixture, we have different types of mixtures. Solid mixture, we have solid liquid mixture, we have liquid mixture, liquid gas mixture, gas and gas mixture and solid and gas mixture. So how do we separate them now? How do we separate, let's say, solid mixture? Suppose you have a mixture of let's say iron filings and sulfur or iron filings and sand. We have a mixture, iron filings and sand. Iron filings and sand. So what do? You bring a magnet. What do we bring? a magnet, North Pole and the South Pole of the magnet. You bring a magnet on over the mixture, all the iron particles will be attracted by the magnet. So we have separated the mixture of iron and sand. Okay, so magnetic substances. In magnetic substances, we like iron, we can use magnetic separation. Okay, using a magnet. So you just have to bring the magnet above the mixture. All the magnetic particles will be attracted by the magnet, thus separating the mixture. Okay. So this is all about separation, magnetic separation. Now, separation of solid-solid mixture, let's say those substances which, let's consider those substances which sublime on heating. Ammonium chloride, naphthalene, camphor, iodine. These are substances that sublime on heating. Benzoic acid, anthracene, and so on. They sublime on heating. So how do we separate the mixture, let's say, of sand and iodine? We have a mixture of sand. We have a mixture of sand and iodine, I. So you know that iodine sublime on heating. So we put it in an evaporating dish, the mixture. We put in the mixture of sand and iodine, we put in the evaporating mixture. It could be evaporating dish, it could be iodine or camphor or naphthalene or anthracene or benzoic acid, anything that sublimes on heating. So over here we have used iodine. We put it in the evaporating dish and cover it up with a funnel. Cover it up with a funnel, and then we plug it up with a cotton wool. We plug the mouth of the funnel with a cotton plug. Now what do? We heat it gently. What do? We heat it gently. What happens is iodine, they sublime on heating. So in the cooler parts of the inverted funnel, we get iodine crystals. So we use the process of sublimation during the separation of any substance that sublimes on heating and the one which doesn't, like for example sand and iodine. So that is how we separate the mixture of anything which sublimes on heating and the other solid which doesn't. Now, separation of solid liquid mixtures. Now, if you want to separate, like let's say a solid like salt, which is salt and water, common salt or sugar and water. You have the mixture here. We have a salt solution, let us say. Now you heat it gently again. What happens is all the water will evaporate slowly. All the water will evaporate slowly, leaving behind only the salt particles. So this process is called evaporation. So evaporation is a process in which liquid is converted into its vapor. Okay? So this is how we get salt from the seawater. Okay? Now, another way which we can use to separate again the salt and water is called distillation. Is called not only evaporation but distillation. But what is the difference between evaporation and distillation? During evaporation, the liquid or the water in this case will evaporate. We will not get back the water. It will just evaporate, leaving behind only the salt. But the same way we can, the same mixture we can use distillation to separate them. But during distillation or in distillation, we can get back water as well. Water as well as the liquid as well as the solid which has been mixed together. So how? I will tell you. So we have a distillation special apparatus. We have a special apparatus of during this is the round bottom flask, and we have a tube passing from the round bottom flask, and then we have a cork, of course. Okay, now we have a mixture of sand, let's say sugar and sugar solution, sugar and water. We have the sugar solution here. Now we have a, let's say, conical flask or the receiver. We have a conical flask or the receiver. Now we have a condenser here. What do we have here? The condenser, okay, which looks somewhat like this. So in the condenser, okay, which the condenser surrounds the tube here. This condenser will just surround the tube. So we have the inlet of water, cold water, and this is outlet of cold water. So there is water all over the tube that is passing through the condenser. So this is the tube which is passing through the condenser. So now what happens is, you heat the mixture or the mixture of salt or the water and sugar. Okay. Now the water molecule, the water will evaporate, and the water vapor will pass through this tube and passes through the condenser, and as the water vapor passes through the condenser, it doesn't directly come into contact with the cold water, but this portion of the tube which is in the condenser will get cooled, and therefore the water vapor, as it passes through the condenser, it will condense back into liquid or water, and then water is collected here in the receiver. So this is the process called distillation, the special apparatus used in the separation of the mixture of liquid and soluble solid, like over here in this case, sugar and water. So what happens again? We heat it gently, of course, and then all the water molecules, water will evaporate, and as it passes through the condenser, it will condense back into liquid, water, and then what is left here? Sugar is left, and we get back the water. So in this process, we are getting back both the constituents of the mixture, the water as well as the sugar. So this is the process called distillation. Now the separation of liquid-liquid mixture. So liquid-liquid mixture also, there are two types. One is miscible liquids, and the other is immiscible liquid. So when we talk about the immiscible liquid, we use the separating funnel to separate it. We use the separating funnel. For example, the mixture of oil and water. We have the mixture of oil and water, and we have a cork here or a stopper here, whatever. Okay. Now this is the separating funnel. So what happens is, we have the mixture of the immiscible mixture of oil. This is the oil and this is the water. All we have to do is open the cork, and we have a receiver here. Now slowly, drop by drop, the water will flow down and it will be collected in the receiver. Now as the level of the water goes down, the level of oil also reaches here. As the level of the oil reaches here, we close the stopper and we get oil here. The oil will be stopped in the separating funnel, and the water is allowed to drop through the separating funnel and collected in the receiver. This is how we separate the mixture of oil and water, or in other words, liquid-liquid immiscible mixture. Okay. Now, suppose we have a mixture, the mixture in which water are mixed together easily, properly, or we have a miscible liquid mixture, like for example alcohol and water mixes very well. Okay, oil and water, they do not mix well, so therefore oil floats on water, we use the separating funnel to separate them. But if we have a mixture of alcohol and water, we use the process of distillation. How? Because water, suppose we have alcohol and water. We have a mixture of alcohol and water, and it mixes very well. So it is a miscible mixture of liquids. So in this case, we use the property of boiling point. They have separate boiling point. Alcohol boils faster than water. Okay, alcohol boils faster than water. That means alcohol evaporates faster than water. So we heat it gently. First, as we heat it, alcohol will evaporate, will boil earlier than the water. So all the alcohol will now evaporate, it condenses back, and then we get alcohol here. Is it okay? We get the alcohol here, and what is left here? After all the alcohol has evaporated, we have only water here, and the alcohol will be received by the process called distillation. And this process, the process of distillation used in separating the miscible liquid, is known as fractional distillation. Okay? So this is all about the separation of mixture, which is very simple. You can go through the activities that is there in your textbook, page number 25, page number 27, page number 29, and page number 30 and 31. So this is how we separate the mixture of different types of mixture: solid-solid mixture, solid-liquid mixture, liquid-liquid mixture, liquid-gas mixture, gas-gas mixture, and solid-gas mixture. So another thing we have to deal with is the most simple way to separate the solid liquid mixture is by using the process called filtration. In the chemistry lab, we use a funnel. And then we get a filter paper. The filter paper is round. We divide the filter paper into half, and then we get a semicircle. Then we fold it again into half of it. So we'll get a cone. So it looks somewhat like this. We get somewhat like this, a cone, 1/4 of the filter paper. Now there will be 4 folds here. We just have to separate 1 and 3 on the other side. So we get a cone. So with that cone, we put it here now. We wet the glass and then we put it here. This is the filter paper now. Okay, this is the filter paper. Now let's say we have a muddy water. Okay, now we pour the muddy water, and we have of course a receiver at the bottom, the beaker, let's say. Then on the filter paper will stop the dust particles or the mud particles or any other particles bigger than the pores of the filter paper. So what happens? Only the water molecules will pass through. Water particles will pass through the filter paper. Okay. So all the mud particles will remain. This is known as the residue. This is known as the residue, and this is the filtrate. The clear liquid which is collected during the filtration is known as the filtrate, and the solid particles will remain behind in the filter paper is known as the residue. So we do the same but the apparatus is different. We do filtration at home, drinking water. The water that we drink, we call it potable water. So that water we always filter it at home. So filtration can be done easily at home. So these are some of the ways in which we can separate the mixtures. Okay? So I hope you understood the separation of mixtures. So in the next class we will talk about the properties of metals and the non-metals. We'll do the next new chapter called metals and non-metals. Okay? So bye for now.